Good morning everyone. Today we are going to learn about mathematical reasoning or fundamentals of logic. What actually is the logic mean? Logic is the science of reasoning, and the logic which we represent using mathematical symbols is known as mathematical reasoning. Throughout this chapter we use statements to represent these logics, and in order to know the statement we have to know what actually the difference between sentence and statement is. Statement is nothing but the collection or group of words, and it can be like interrogative, exclamatory, anything. But statement does not take interrogative, exclamatory in this chapter, I mean logics. But remember that statement is a type of sentence which is either true or false, but not both. What does it mean? Exactly, the sentence should be true or false, but there should be not like confusion. And we represent the statements using small case letters. Here P is the representation of a sentence. Let P be the sentence I am giving. It is raining. If it is really raining, we can say that statement P is true. Otherwise, the statement P will be false. And also, we need to know that the sentence classification. Sentence is of two types in general: simple sentence, compound sentence. What is the difference between them? Simple sentence is only one sentence. Means here I have written, right, it is raining. It comes under simple sentence. Whereas compound sentence is nothing but they are the collection of sentences which are joined using connectives. Let me consider an example for compound sentence. Q. I like chocolate and ice cream. Here and is said to be the connective. Why I will explain now. It is compound sentence. Why? From this we can derive two sentences. I like chocolate, I like ice cream. Instead of writing two sentences, we are simplifying it into one sentence. That is the reason this is known as compound sentence. And how it can be simplified is using connectives like this, and or we can use those all. Now we are going to discuss about logics. First, negations. Completely I am erasing. Negation. What actually is negation mean? Now we will have a statement. For example, P be a statement. Then opposite of P is said to be the negation of P. Means what? Let P be a statement. You consider it is raining. It is P. And one more thing is how we represent this negation using this symbol or sleeping 7. And for P, how can we represent its negation is negation P or negation P. Don't confuse, because in exam sometimes they may give this symbol or this symbol. Now we have given here P, it is raining. What will be the negation of it? It is not raining. It is not raining. Now we need to also discuss the truth table for it. Truth table. Yeah, before going for truth table of negation, I want to discuss one main thing. The number of sentences you use in the truth table. Means here we have considered only P. Means one sentence, right? Like that, if we consider n sentences, in truth table we need to take 2 power of n values inside it. Here since we have considered only one, what is it? P. P means one sentence, right? N equal to 1. which implies 2 power of 1, nothing but 2. Two values we will get inside it. One you will give P and one more for negation P, truth table. And why we have given that 2 power n is, we know that statement means it can be either true or false. Means two cases, right? That is the reason we have given 2 to the power of. And here P, it is raining. It can be either true or false, but not both, right? When it will be true, what will be negation P? Opposite of true. False. Here opposite of false, true. This is what truth table for negation. And we have to remember one more thing is, in negation we work only with one sentence, nothing but simple sentence. Remaining all we are going to work with compound sentences. You make a note of it. Now I am going to explain another thing. Compound sentences, as I told, we use connectives. What are connectives? We are going to cover. I will show now. Connectives. Connectives like and, or, if and only if, and if then. Those all we use as connectives. Now we will discuss in the same order. And first. And one more thing before starting it, I want to explain its real life application where we use all this, and why we need to study is, we generally use in computer systems, I hope everyone know that we use logic gates. There also we discuss that AND gate, OR gate, XOR, NAND, NOR, and those all we do with 1 and 0 values, right? Here those 1 and 0 same we use here, nothing but using this they have found this one. True is nothing but 1 and false is nothing but 0. Sometimes in question they will always they won't mention true or false. Sometimes they also mention like this. And one more application is, in AI we use knowledge based systems. For example, if we take ChatGPT, how it gets information? A person or someone gives the information or the knowledge for it, so that it gets the information from the particular source. And that is how there we apply. And now coming to and, let me give numbering. This is first one. Now we are going to discuss about and we are going to represent like this. This is the symbol for and is nothing but conjunction. You have to know the difference between conjunction and disjunction. Yeah, now coming to and is the conjunction, and it is used between two simple sentences. That's the reason we use and in compound sentences as connective. And we need to know the truth table for this. And before knowing the truth table, as I told, it is used between two simple sentences. You need to take here two sentences. Let P be one sentence, Q be one sentence, and P and Q. And as I told you, 2 power of n possibilities will be, where n is number of sentences. Since we have used 2, we will get 4 in this truth table. P is true, Q is true. P true, Q false, P false, Q true, both are false. Here we need to know one more difference, that and in logic gates, AND gate, there we have learnt as multiplication. See, in the similar way only in mathematical reasoning also, if both are true, then it will be true. In remaining all cases, it will be false. And let me consider an example. I like chocos and chips. From this we can write two sentences, right? Let P, let Q. P means I like chocos, I like, and Q means I like chips. How can we represent this entire symbol is P and Q. What actually is the difference is they will give like this sentence and they will tell to represent it logically. Then we need to do like this, where P is I like chocos and Q means I like chips. Combination of those, and so here P and Q we will say for it. Next, similarly, now OR we will discuss. OR. OR is also known as disjunction. Now, truth table for OR. Same, it is also used between two sentences. Like in real life, we will use either or, neither nor. In such cases, we use this. P, Q, P or Q. Same. These four will be same, but the last column will be different. True, 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 false, false, true, false, false. If at least one statement will be true, here output will be also true. True, 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 false. Similar example I will take. Instead of and, we write or in that for that example, or, and here also we need to change. Here also same. I like chocos, I like chips. I like chocos or chips, or we represent using this symbol. And remember that they won't always mention and or. If they say conjunction, we need to do for and if they say disjunction, then we need to do for or. Next we will see if then. If P then Q, it is also called as. If then. If then. If then is nothing but if in other subjects like artificial intelligence, any subject, it is known as if condition then action. Nothing but I hope everyone are aware of computer programming languages. If condition is true, then only the conditional statement will execute, right? Like that only. If condition will true, then only action takes place. Nothing but if first statement, then second statement. Here in mathematical reasoning, we have to say like that. And let me do truth table for this. Representation of that is we use this symbol. Right arrow. Truth table. Same we use only two statements. So we are writing PQ. P or Q. These will be same true, 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 false, false, true, false, false. Here true implication true. It means that if condition is true, then action. So it is true. True implies false is false. False implies true, true. False implies false also true. Only this case. Means when first statement will be true and second statement will be false, then only the result will be false, else true in other cases. Now next we will see if and only if. Sorry, this is fourth. Next, fifth is if and only if. If and only if. Here we use by implication symbol. By implication means from right arrow, left arrow in single. Don't use this symbol where in generally we use this symbol, right? But you should not use in mathematical reasoning or logics this symbol. Why I will explain after some time. Now similarly truth table. P, Q, P if and only if Q. Yeah, and the values inside this truth table, this we will call it as truth values. Means does not mean that all are true. Truth values means truth and false values are only going to present in this table. True true, true false, false true, false false. Yeah, when both the statements will be similar, means either both are true, both are false, then only the resultant is going to be true and false in remaining cases. Now next, sixth one we are going to see. Exclusive OR. In logical gates we say this one as XOR. Exclusive OR. Still here you make note of it, I will continue. Yeah, exclusive OR is completely opposite of if and only if. Truth table for exclusive OR is, before that how we represent this, using this symbol or we use another symbol. OR is enough, for that one you need to keep bar. It means P or like this also you can represent. Now truth table we will see P, Q, exclusive OR. True true, true false, false true, false false. Yeah, as I told, it is completely opposite of if and only if. What does it mean is, when both the truth values of the statements are similar, then it becomes false in this case. Whereas in if and only if we mention true. And if both are different, there we get true. This is what exclusive OR. Next we are going to see NAND and NOR also. Yeah. Now coming to seventh one, NAND. NAND and eighth one, NOR. It is nothing but negation of AND. Negation of AND. And NAND symbol we represent using this up arrow, NOR we represent using this down arrow. And this is known as, here it is negation of OR. Yeah, we should not represent with this equal to symbol. That is the main thing I want to explain you. We represent using this symbol or this symbol. This means that equivalence. In general, we represent 2 plus 3 equal to 5. Means in discrete mathematics or logic, these symbols represent equivalence relationship. Up arrow, here down arrow mark. And truth table for this one. Truth table. P, Q, P up arrow Q. Here also P, Q, P down arrow Q. To not get confusion, here itself I will also explain the AND and OR again. P, Q, P and Q. Here P, Q, P or Q. Then you will know the difference between those. Write down the truth values. True, 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 false, false, true, false, false. Here also same. True, false, true, 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 false, false, true, false, false. You can write in any order also, but to get easily understand, I am writing that order. And in and we know that this we follow, whereas in or we follow this one. Now it is negation of and. Negation of and means opposite of this truth values we will write here. True, negation is false. Here. False, 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 true. With this, the logic's truth tables we have completed. But truth table does not mean only for these 8 properties we do. The main problems we will discuss now. These are the things which we need to learn so that we can solve the problems now easily. I hope everyone completed. Yeah. In exam we get questions to draw truth table for this kind of questions. Then then it is simple. Here first notice how many statements we are using in the question. Statement P is available, Q is available, R is also available. Means 3 statements. First write here P, Q, R. Then any negations you are using for these statements? Yeah, negation P and negation R you are using. Write those. Negation P, negation R. 1 minute. Board will not be sufficient. Let me write those near. P, Q, R. Negation P, negation R. Next, now go bracket wise. Don't do blindly P implication Q, because there will be lot of changes in the resultant. As they mentioned in brackets, you need to follow that order. Q if and only if negation R you need to do. Let this entire thing be in W. Then P implication W we need to find. This one you treat it as X. Next, negation P and Q you need to do. Let it be Y, and here separately R and negation P. Let it be Z. Y or Z you need to do. Yeah, one more place bracket is missing. Yeah. Y or Z you will do, right? Let it be in V. Then what actually you need to find? X implication V. This will give you the final output. Now, how you need to take truth values? Still now in examples we have considered only 2 statements. Means 2 squares. So 4 values. Here 3 statements. 2 cube means 8 possibilities we will get. What are those? You can write simply like in probability for tossing of coin you will write head, head, tail, tail, tail. In similar way we will write. But for easy understanding I am making you explain. First write 4 trues, then 4 false. Here for 2 you need to write true true, false false, true true, false false. And every alternate you need to take true false, true false, true false, true false. Yeah, now do we get 8 possibilities? Sorry, there was a small technical issue. And here for P and R, since we computed those values, you need to simply enter negation of those values. Here since 4 true, false, false, true. Here alternately true, false we have written, so here alternately false, true. Now what we need to compute? Q if and only if negation R. If you remember, in if and only if condition, I told that If truth values of both the statements are similar, then only resultant will be true. Otherwise, it becomes false. For what we are finding? Q, negation R. True, false. False, true, true. True, false, false. True, false, true. False, true, false, false. Because both are different, observe it clearly. Here true, true. Both are similar, so true. False, false. Similar, true. Different, so false. Now we need to find P implication W. What is W? Q if and only if negation R. And now coming to if and only, now coming to implication. True implication false, then only resultant will be false. Otherwise, in all the remaining cases, it will be true. Now P. Don't take negation P. P. True implies false. False means for simple understanding, whenever second statement is false, then only you observe first statement. Otherwise, you can take simply true. True. Yeah, here false. So what is P? True. True implies false. False. False implies false. True. Here also true. True. False implies false. True. Here we have computed X. Now keep this one aside. This is, for this we represent using X. Now negation P and Q. Negation P and false and true. False. False and true. False. False and false. False. False and false. False. True and true. True. True and true. True. True and false. False. True and false. False. This is what and. Since we have done and already, here a small change I am doing. Take it as or. R or negation P. R or negation P. At least one true, it will be true. True, false, true, false, true, 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 true. Now Y or Z. What is Z? R or negation P. Y or Z we need to compute. This entire part is Y, this is Z. Y or Z. If at least one true, it will be true, otherwise it will be false. Now we have stored it in V. What we need to find? X implication V. Means this P implication W implication Y or Z we need to find. X. False implies true. True. True implies false. False. True implies true. True. False. False. True. 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 True implies true. True. True implies true. True. True implies true. True. This is what the final answer we get. Such kind of questions we will be getting in theories. Now we are going to discuss about tautology, contradiction, contingency. Since now we have come across compound statements and we found the truth values for it. Truth values nothing but in the before question, if you see, we have found the last column all the truth values, right? If those all becomes true, it is tautology. All are false means contradiction. Few true, few false means contingency. It is nothing but a compound statement whose truth values are always true. Means all must be true. Then it is tautology. If all are false, it is contradiction. If it contains few truth values as true and few as false, means like true, true, false, true, like this, means it is both the mix of true and false values, right? That is known as contingency. If all are false, then contradiction. If all are true, then tautology. They will give the similar kind of question and they will ask to prove whether it is a tautology, contradiction or contingency. Now let me take an example. P and Q, implication P or Q. We need to prove what actually it is, tautology, contradiction or contingency. Since only two statements, write down first. Possibilities only 4. True, 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 false, false, true, false, false. Now, first P and Q you compute, then P or Q. Let it be X, let it be Y. We need to find X implication Y, what actually it is. P and Q. This is like AND table, and this is for truth OR table. And X implication Y. This is X and this is Y. True implies true, true. All are true. Since all the values are true, means this is the compound statement whose truth values are always true, is tautology. Therefore, the given statement is said to be tautology. In similar way, we can prove contradiction and contingency also. If he will tell, let me remove this, only P and Q if he asks. Yeah, in P and Q what we have received? We received true, false, false, false. Means not all are true or not all are false. It is mixed. One true or many falses, anything it can be. This is said to be example of contingency. If all values will be false, then it is said to be contradiction. Now another concept we are going to discuss is converse, inverse and contrapositive. It will be found only for P implication Q. You must remember that one. Remaining all theoretical questions I will explain after this. Converse, inverse, contrapositive for P implication Q. First write down converse, inverse, contrapositive. Contrapositive. Yeah, for P implication Q, converse is Q implication P. Inverse of P implication Q is negation P implication negation Q. Whereas contrapositive is combination of both converse and inverse. Nothing but negation Q implication negation P. It means we can define contrapositive as converse of the inverse. Converse of the inverse means what? First we need to find inverse. Inverse of P implication Q is this one. And the converse of this one means this will go that side, that will come this side. Negation Q implication negation P. That is what we have received here. This is what converse, inverse and contrapositive. Now one more problem we will discuss. P if and only if Q is logically equivalent to negation of P XOR Q. You need to prove this one. How we will prove is simple. Remember that don't confuse for these symbols. If we give this symbol or this symbol, it means equivalence. Nothing but in our terms we can say equals to. That is true or not, we need to prove it. First, since only two statements, write down P, Q. We need to find P if and only if Q. Next, P XOR Q. And negation of this one we need to do. Let it be X, negation X. And we need to prove whether this and negation X are equal or not. Now we are going to prove it. Take the truth values. Now, if and only if. If and only if means When truth values of both the statements are similar, the resultant will be true. Otherwise, it will be false. In XOR, it is opposite of this if and only if. False, true, true, false. And now what he is saying, we need to negate the X. Nothing but negation of XOR. What will get? True, false, false, true. Yeah, now if you see the truth values of this both are equal. Means else this condition is correct. We need to write. Because he is asking to prove whether they both are logically equivalent or not. This is a symbol of logical equivalence, or simply like this one also they can give. Don't confuse what this and this. This means if and only if. In mathematical reasoning we represent like this only. Yeah, this is how we can solve.